Hello, I'm the Code Architect. Today, we're diving into LangChain custom agents, building specialized AI assistants.
All right, let's just dive right in. We're about to take a pretty huge leap, moving from just talking to AIs to actually building them. Seriously, forget being a consumer. Today, you're going to become a creator, and we're going to build our very first AI agent using a really powerful framework called LangChain. Just think about it for a second. You've probably chatted with dozens of AIs, right? But have you ever given one a real job to do? A goal, a set of tools, and then just the freedom to figure out the steps all on its own? Well, that's the big difference between a simple chatbot and an agent, and it's exactly what we're building today. So what is the big difference, really? What separates a chatbot from what we're calling a true AI agent? It's actually a really fundamental distinction, and getting this is the very first step to building something powerful. See, an agent is way more than just a conversational partner. It's an AI that can actually reason and make decisions. It doesn't just sit there waiting for your next prompt. It has a goal, and it actively chooses which actions to take, which tools to use to get there. You can almost think of it like an autonomous worker. This brings us to the core idea of how these agents work, something called the react pattern. It's super simple, but incredibly powerful. The agent combines reasoning with acting. It thinks about the problem, and then it does something about it. This simple loop is the engine that drives absolutely everything. And here's what that react pattern looks like in action. It's this continuous loop. First, the agent reasons about the goal. Then it acts by picking a tool and using it. Next, it observes whatever came back from that tool. And finally, it repeats the whole process, deciding its next step based on that new information. It just keeps cycling through until the job is done. Okay, so the concept is pretty clear, but what do we actually need to build one of these? What's in the toolkit? Well, it really just comes down to three essential ingredients. First up, tools. You should think of these as the agent's hands. An LLM by itself is basically just a brain in a jar. It can't check the weather, it can't search the web, it can't access your database. Tools are the functions we write to give it these superpowers, letting it actually interact with the outside world. And here's what that looks like in the code. It's surprisingly simple. See that @tool decorator right above the function? That one little line is kind of LangChain's magic. It automatically registers this Python function, getWeather, as a capability our agent can just choose to use. Okay, second ingredient, the prompt. If the tools are the agent's hands, then the prompt is its job description. This is the absolutely crucial set of instructions that tells the agent who it is, what its goal is, and the rules for how it should behave. Now, in its simplest form, a prompt can be just a single sentence, like this one right here. You are a helpful assistant. And this is a great starting point, but as we're about to find out, the real power comes from making this prompt much, much more detailed. And the final piece of the puzzle, the LLM, the large language model. This is the brain of the whole operation. It's the reasoning engine that looks at the user's request, reads our instructions from the prompt, checks out the available tools, and makes that crucial decision. Okay, what do I do next? So there we have it, our three ingredients, a tool, a prompt, and an LLM. We have all the pieces. Now for the really fun part, how do we actually stick them together and bring our agent to life? Let's jump from theory straight into the code. And this right here is the big aha moment, visualized perfectly. We just take our three ingredients, the model, the tools, and the prompt, and we feed them all into this one magical function, create agent. LangChain handles all the tricky stuff in the background, and out pops a fully functional agent. It's that simple. So now, let's run it. We call the .invoke method on our new agent and pass in the user's question, what is the weather in SF? At this very moment, the agent's brain, the LLM, kicks into gear. It sees the question, it looks at its available tools, and it realizes, hey, I have a getWeather tool, and decides to call it. That's reasoning and acting, all in one step. Okay, awesome. Our basic agent works. That is a huge step. But what happens when things go wrong? Or when you need a lot more control? A production-ready agent needs to be way more robust and sophisticated. So it's time to level up. This might be the single most important lesson of this entire explainer. The quality of your tool descriptions is everything, seriously. On the left, you've got a confused agent with vague instructions. On the right, a confident agent with a detailed plan. And why? Because that detailed description is like a mini prompt that tells the LLM exactly when, why, and how to use its tools. Better descriptions always lead to smarter decisions. So, what other pro features do we need? Well, to make our agent more aware, we can give it what's called runtime context, maybe a user ID. To make it more reliable, we can force it to return structured data instead of just plain text. And to make it smarter over time, we can give it memory. Oh man, memory is an absolute game changer. It is the difference between a tool that just answers one-off questions and a true conversational partner. With memory, the agent can actually remember what you've already talked about, which allows for natural follow-ups and a much more human-like experience. And once again, LangChain makes a really complex feature seem incredibly simple. We just import something called a checkpointer. In this case, it's an in-memory saver, and we add it to our agent's configuration. And just like that, our agent now has memory. It's now stateful. You know, we've covered a ton of ground here. So, as you start your own journey building agents, what are the key best practices and the common traps you need to watch out for? Let's just recap the essentials. Here's your checklist for success. Number 1, nail your tool descriptions. Remember, they are basically prompts for the LLM. 2, start simple. Please, just get one tool working perfectly before you even think about adding a second. 3, use structured output whenever you can for reliability. And 4, add memory to turn your agent into a real conversational assistant. It's also pretty helpful to see the evolution here. The create agent function we've been using, that's the modern standard. But for those truly complex production-grade systems where you need explicit control over loops, error handling, maybe even human-in-loop steps, the future is something called Langgraph. It gives you the ultimate control over the agent's flow. And with that, the journey is complete. You've seen the concepts, you've seen the code, and you've seen the path forward. You have officially gone from just using AI to understanding how to build a custom agent that actually works for you. So, I'll just leave you with this one question. You now have the fundamental building blocks. You've got tools, prompts, and a reasoning engine. You know how to put them together. The only thing left to decide is, what problem will you build an agent to solve first?
Like, share, and subscribe to my channel for more AI insights. I'm the Code Architect. See you soon.